We're going to continue Unit 2 with proving angle pair relationship. So this is going to be some more proofs. Sometimes a new theorem describes a relationship that is useful in writing proofs. So, for example, we're going to prove the right angles congruence theorem. This will reduce the number of steps that you need to use in proofs involving right angles. So the right angles congruence theorem states that all right angles are congruent. So the first thing that we need to do is write that as a conditional. Then our given is going to be the hypothesis, and what we're trying to prove is going to be the conclusion. So our conditional statement is if two or more angles are right angles, then they are congruent. So we're going to draw a picture. We have two right angles, angles 1 and 2, and I'm trying to prove that angles 1 and 2 are congruent. So my first statement says 1 and 2 are right angles. Well, that's my given. Saying that their measures are 90 degrees is the definition of right angle. Now saying that measure angle 1 equals a measure angle 2 is basically saying statement 2. So if I say if measure of angle 1 equals 90 degrees and the measure of angle 2 equals 90 degrees, then measure of angle 1 equals measure of angle 2, which is the transitive property. And then saying from measures equal to angles congruent is the definition of congruence. All right, so we're going to use this. I'm going to use that in writing a proof about this diagram here. We are given that segment AB is perpendicular to segment BC, and DC is perpendicular to segment BC. We're trying to prove that angle B is congruent to angle C. So my statements are written there. The first one is our given. And to say that B and C are right angles, well, we're told they're perpendicular, and we know perpendicular lines form right angles. So that's the definition of perpendicular lines. And then saying that we have two angles are right angles and that those two angles are congruent is that theorem we just proved, which is all right angles are congruent. We have a couple more theorems. We have this congruent supplements theorem where it says if I have 1 and 2 are supplementary and 2 and 3 are supplementary, then 1 and 3 are congruent. So it's if two angles are supplements to the same angle, then those two angles are congruent. Likewise, with the complements theorem, congruent complements theorem, if two angles are complements to the same angle, then those two angles are congruent. We're going to write the proof of the congruent complements theorem. Okay, there are two cases. We're only going to do one. The first one is that 1 and 2 are supplements, 3 and 2 are supplements, and we're trying to prove that 1 and 3 are congruent. So the first statement, 1 and 2 are supplements, 3 and 2 are supplements. If you look, that is your given. Saying that measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 3 plus the measure of angle 2 is equals 180 is the definition of supplementary angles. It's my abbreviation for angles. Measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. That's your if and then statement, so that's your transitive property. That's my cat trying to give instruction also. I don't know if you can hear him. Saying the measure of angle 1 equals measure of angle 3. Look at what's happening. You're getting rid of measure of angle 2 by subtraction. And then going from measures are equal to angles congruent is a definition of congruency. We're going to kind of work through the guided practice together. How many steps do you save in the proof in example 1 by using the right angles theorem? Well, if you look back at how many steps it took us, you basically are saving 2 to 3 steps. We're going to draw a diagram and write the given and proof statements for our proof of each case of the congruent complements theorem. Okay, so case 1 is that the complements to the same angle. Okay, so I'm going to draw something very similar. Label 1, 2, and 3. And our given is going to be that one and 2 are complements. And 2 and 3 are complements. And then we're trying to prove that angle 1 is congruent to angle 3. Okay, so that's one case. The second case is that we have one, two, three, four. Is that we have one is complementary. I'm going to abbreviate that to angle 2. 3 is complementary to angle 4. Angle 2 is congruent to 4. That's going to be all our given. We're going to try to prove that 1 is congruent to 3. And that is it for day 1.